So we know that reversible chemical reactions want to reach the energetically stable condition known as equilibrium. And one of the ways that we quantify equilibrium is through something known as a equilibrium constant, symbolized by capital letter K, which is a constant for any given chemical reaction at a specific temperature. And the equilibrium constant, in its simplest definition, is really a ratio of the concentration of products to reactants. Let's look at how an equilibrium constant is calculated. An equilibrium constant is determined based on plugging into this chemical equation known as an equilibrium expression. An equilibrium expression always has K on the left-hand side, and on the right-hand side we have a fraction where we have in the numerator the concentration of each product taken to whatever power that is equal to the coefficient in the balanced chemical equation. So here in this chemical equation we have products C and D, and in the numerator we have the concentration of C taken to the coefficient lowercase c, and then we have the concentration of D taken to the power of lowercase d. These two values are multiplied by one another and then divided by the same pattern from our reactant side. Concentration of A taken to the power of whatever coefficient is in front of A, multiplied by the concentration of B, which is taken to whatever power this coefficient of B is. So it's useful to see this applied to an actual chemical equation. So here we have a chemical equation. N2 plus 3H2 is in equilibrium with 2NH3. So to write the equilibrium expression, we have K on the left-hand side, and then on the right-hand side we have our ratio. In the numerator is the concentration of our product, ammonia, taken to the second power, because it has a coefficient, ammonia has a coefficient of 2 in the balanced chemical equation. In the denominator, we have the concentration of our reactants, nitrogen and hydrogen. And hydrogen is taken to the third power because in the balanced chemical equation, it has a coefficient of 3. So just so you know, the way that K is calculated is that at equilibrium, these concentrations of ammonia, nitrogen, and hydrogen at a given temperature is plugged into this equation, and then we get some value for our equilibrium constant. Now, an important thing to know is that in an equilibrium expression, only the reactants and products that are either in the gas or aqueous phase are included, because those are the chemicals that have a changeable concentration. Pure liquids, so chemicals with a phase of L, and pure solids, so chemical with a phase of S, are not included in the equilibrium expression.